In the last video, we evaluated the limits of some rational functions. And maybe from the student perspective, it was a little bit frustrating or tedious to watch these, because really we're just solving problems that you already knew how to solve from a pre-calculus class using slightly different techniques and notation. Hopefully I've built up enough trust over this class where you're like, he's probably teaching me this for a reason, so I'm going to go ahead and learn what he's doing. Well, I can start to demonstrate that reason in this video. In this video, we're again going to consider the limit as x approaches infinity and negative infinity of various expressions. But now those functions won't just be the quotients of polynomials. Now we're going to involve some radicals in here. What if you had to figure out the limit as x approached infinity of the square root of 6x to the fourth minus 5x squared plus 7x plus 11 divided by 2x squared plus x? Well, we learned this technique in the previous video where we just divided both the top and the bottom by x raised up to whatever the degree of the bottom was equal to. It'd be nice if we could do something really similar in this video so we don't have to learn a new technique. And it turns out we can. In fact, in this first example, we're going to start out the exact same way. The degree of the denominator is 2, so I want to divide everything on the top and everything on the bottom by x squared. Let me start with the bottom. I'd have the limit as x approaches infinity of 2x squared divided by x squared, which is just 2, plus x divided by x squared, which is 1 over x. Unfortunately, things are a little bit more challenging on the top. Dividing everything on the top by x squared is the same as multiplying everything on the top by 1 over x squared. But it's a little bit hard to multiply everything on the top by 1 over x squared because I have this radical that's kind of hiding everything. How do I get this 1 over x squared inside this radical? Well, there's a little trick to it. 1 over x squared is the same as the square root of 1 divided by x to the fourth power. So I can replace this 1 over x squared with the square root of 1 over x to the fourth power. And then I'd have the square root of something, 1 over x to the fourth, times the square root of something else, all this stuff. And the square root of something times the square root of something is just the square root of that product. What I'm saying is I can take this 1 over x squared and put it inside the radical if I make it 1 over x to the fourth power. If it's 1 over x to the fourth power, then I have 6x to the fourth divided by x to the fourth, in other words, 6. I have negative 5x squared divided by x to the fourth power, in other words, negative 5 over x squared. I got 7x over x to the fourth, in other words, 7 over x cubed, and then I have 11 over x to the fourth power. Again, taking advantage of my limit laws, I can take the limit of the top and the limit of the bottom. The limit of the square root of something is just the square root of the limit of that something, and the limit of a sum of terms is just the sum of the different limits. What I'm saying is I can evaluate the limit as x approaches infinity of each of these different 6 terms individually. I'd end up with the square root of 6 minus 0 plus 0 plus 0 divided by 2 plus 0. I'd end up with the square root of 6 divided by 2. The limit as x approaches infinity of this expression is root 6 over 2. We're really using the same techniques that we did in the previous video and one new algebraic trick, but we're coming up with an answer that we couldn't have come up using the pre-calculus methods from an earlier class. Let's do another example. This example is much trickier than it looks. In fact, as I work through the problem the first time, I'm going to get the wrong answer, and then I'm going to explain to you why my answer is wrong and show you how to not make the same mistake that I'm about to make. Let's start attacking this problem in a kind of naive way by just doing the exact same thing that we did above. We might even be able to cut out some steps. The first thing I might recognize is that the degree of the bottom is 3. So I want to divide everything in the bottom by x cubed, and I want to divide everything up top by x cubed. So up top, I got 1 over x cubed times the square root of 4x to the 6th minus 5x squared plus 7x plus 11. And down in the bottom, I got 2x cubed divided by x cubed, plus 1 over x squared, x divided by x cubed. Earlier, I said that 1 over x squared is the exact same as the square root of 1 over x to the fourth. So you might think that 1 over x cubed should be equal to the square root of 1 over x to the 6th power, right? That would make a lot of sense. Well, if that were true, then what I could do is say that this is equal to the limit as x approach negative infinity of, and make this 1 over x to the 6th and put it inside of the radical. For 1 over x to the 6th inside of the radical, I'd have 4x to the 6th divided by x to the 6th, so I just have a 4. I'd have negative 5x squared divided by x to the 6th, so I'd have negative 5 over x to the 4th power. My 7x over x to the 6th would turn into 7 over x to the 5th power, and then I'd have 11 over x to the 6th power. At this point, I'd be able to evaluate this limit. Using some limit laws, I can say that up top I have the square root of 4 minus 0 plus 0 plus 0. And down on the bottom, I could say I have 2 plus 0. I can say that this limit is just the square root of 4 divided by 2. In other words, 2 divided by 2. In other words, 1. It sure does appear that the limit as x approaches negative infinity of the square root of 4x to the 6 minus 5x squared plus 7x plus 11 divided by 2x cubed plus x is equal to 1. Just for the hell of it, I'm going to take this expression right here and I'm going to type it into Desmos. The square root of 4x to the 6 minus 5x squared plus 7x plus 11 divided by 2x cubed plus x. Remember that what I was interested in is the limit as x approaches negative infinity. In other words, what happens to this graph when I go way out to the left? It appears that the height of this graph is approaching, negative 1 here. Right? If I zoom out, we see this horizontal asymptote, and it looks like the height of this asymptote is at negative 1. But that's really strange because we just did all this analysis, and we figured out that the limit as x approaches negative infinity is positive 1. So what's going on here? Where did our algebra fail us? Well, it turns out that what went wrong was this step right here. 1 divided by x cubed is not equal to the square root of 1 divided by x to the 6th. 1 divided by x squared is equal to the square root of 1 divided by x to the 4th, but 1 divided by x cubed is not equal to the square root of 1 over x to the 6th. Why? What's going on here? Really what it comes down to is the fact that the square root of x squared is not just equal to x. The square root of x squared is equal to the absolute value of x. X and the absolute value of x are almost the same. In fact, they're exactly the same when x is not negative. But when x is a negative number, these produce different results. For that reason, really what I should have written up here is that the square root of 1 over x to the 4th power isn't 1 over x squared, but instead 1 divided by the absolute value of x squared. But really up here, it doesn't matter at all. Because I still need to square this thing, it doesn't matter if I take the absolute value or not. The absolute value is just going to make this thing positive, but whether it's positive or negative, when I square it, I get the same value. Squaring gets rid of the negatives, so I don't have to worry about the absolute value symbol here. But down here, I'm not so lucky. The square root of 1 over x to the 6th is not 1 divided by x cubed, but instead 1 divided by the absolute value of x cubed. And unlike 1 over x squared and 1 over the absolute value of x squared, 1 over x cubed and 1 divided by the absolute value of x cubed are very different. Because if x is a negative number cubed is negative. But if x is a negative number, the absolute value of a negative number is positive, and a positive number cubed is positive. Whoa, you've completely lost me. Can you please just tell me how to get the right answer? I mean, yeah, I guess there's a couple different options. Really what's going on is from this line to this line, we can't just make 1 over x cubed the same as the square root of 1 over x to the 6th power. Because the square root of 1 over x to the 6th power is not 1 over x cubed, it's 1 over the absolute value of x cubed. So what can we do? Well, my advice is just to solve these the same way you've been doing them. But anytime you have a radical either in the top or the bottom, check your answer at the end. What do I mean check your answer? Well, up here, if x is a positive number, x to the 4th is going to be a positive number, and the square root of a positive number will be a positive number. And down on the bottom, if x is a positive number, x squared is going to be a positive number. So I have a positive divided by a positive. My answer should end up being positive. It is. I must have done the right work. Down here, when x is a negative number to the 6th power becomes positive, and the square root of that positive number is positive. However, down in the bottom, a negative number cubed is negative. So up here, I had a positive divided by a positive. Down here, I have a positive divided by a negative. And when I divide a positive number and a negative number, I get a negative number. All of the logic is sound numerically, but because of this fact, I know that this answer can't be positive 1 and instead should be negative 1. If you really want all your work to be correct, we could trace these negative signs all the way back to this step, because it was the process of bringing this 1 over x cubed into this radical where things went wrong and caused my answer to be off by a negative. But really, if you're just concerned about your final answer being correct, just remember to double check your answer at the end anytime you're involving radicals. Tricky, huh? Let's do one more of these. In fact, let's do 2 more of these. Let's look at the limit as x approaches negative infinity of 7x plus 11 divided by the cubed root of 2x cubed plus x. And then let's look at the limit as x approaches negative infinity of 7x squared plus 11 divided by the cubed root of 2x to the 6th power plus x. If you're the overachieving type, you might want to watch me solve this one and then give this one a shot on your own. How would I solve this one? Well, first comment is what we've been doing so far, this little trick, is we've been looking at the degree of the bottom and then dividing the top and the bottom by x raised up to that power. However, in this case, in the denominator, we have this cubed root. So even though you might think that the degree of the bottom is 3 for this x cubed, the degree of the bottom acts more like a 1, the cubed root of x cubed. Because the cubed root of x cubed is equal to x to the 1st power, we should divide the top and the bottom by just x raised up to the 1st power, or x. If we do that, we get the limit as x approaches negative infinity of 7x divided by x, in other words 7, plus 11 divided by x, divided by 1 over x times the cubed root of 2x cubed plus x. Much like we saw before, we can just take the 1 over x and distribute it to all the terms up on top, but down on the bottom, because I have a radical, I can't immediately distribute the 1 over x to each of these terms. What I instead have to do is take advantage of the fact that the cubed root of 1 over x cubed is the exact same as 1 over x. So instead of thinking about this as 1 over x, I can think about it as the cubed root of 1 over x cubed to get that this is the limit as x approaches negative infinity of 7 plus 11 over x divided by the cubed root of 2x cubed divided by x cubed, in other words 2, plus x divided by x cubed, in other words 1 over x squared. At this stage, I can use my limit laws to evaluate each of these terms individually. I get 7 plus 0 divided by the cubed root of 2 plus 0. I get 7 divided by the cubed root of 2. At this point, you might be a little bit nervous. You're like, right, but is that the right answer with these radicals? Now I'm all confused and not sure when I have the right answer and when I don't. We can always check your answer. If x is a large negative number, the top's going to be negative. And since a negative number cubed is still negative, and the cubed root of a negative is still negative, the bottom's also going to be negative. So I'm going to have a negative divided by a negative, which produces a positive, which is exactly what I got here. My answer must be correct. Can we do those same steps over here? I think so. Now, because the cubed root of x to the 6th power is equal to x squared, we're going to divide the top and the bottom by x squared. If we do that, we get the limit as x approaches negative infinity of 7x squared over x squared, in other words 7, plus 11 over x squared, divided by 1 over x squared times the cubed root of 2x to the 6th plus x. But in much the same way that 1 over x is the same as the cubed root of 1 over x cubed, 1 over x squared is the same as the cubed root of 1 over x to the 6th power. So instead of thinking about there being a 1 over x squared here on the bottom, think about there's a 1 over x to the 6th inside this radical, which changes this 2x to the 6th into 2x to the 6th divided by x to the 6th, in other words, just 2. And it changes this x into x over x to the 6th, in other words, 1 over x to the 5th power. This is a limit that I can evaluate using my limit laws. I get 7 plus 0 divided by the cubed root of 2 plus 0. I get 7 over the cubed root of 2. The exact same answer that I got over here. Is this answer correct? Well, because I have radicals, I should probably check my answer. If x is a large negative number, since a negative number squared is positive, the top is going to end up being positive, unlike what we saw over here where the top was negative. What about down on the bottom? Well, a negative number to the 6th power is going to be positive, and the cubed root of a positive number is also going to be a positive. A positive divided by a positive is a positive number. My answer should be positive just like it is. I got the right answer over here as well. These answers are the same, but for kind of different reasons. This answer is 7 over the cubed root of 2 because a negative divided by a negative is a positive number. And this answer is 7 divided by the cubed root of 2 because a positive divided by a positive is a positive number. Big takeaway here is you can do tricks that are pretty similar to the tricks that we did in the previous video when you have radicals, but you have to be careful of a couple of things. This idea of dividing the top and the bottom by whatever the degree of the bottom is still kind of true. You just have to be a little bit careful if you have radicals in the denominator, because in that case, the degree that you see, 3 in this case, isn't really the effective degree of the denominator. The denominator acts more like something that's raised up to the first power. The other trick is it's really easy to lose negative signs within these radicals. Squaring things and taking square roots don't really just cancel out in math, even though a lot of people think that they do. In the case where that thing you are squaring and then square rooting is negative, you can lose track of that negative sign. And that makes things really challenging in these examples. But fortunately, there's a fairly easy solution. Just remember at the end to always check the sign of your answer. The numbers won't go wrong. You'll just lose a positive or negative, and you can put that back in at the very end if you need. There's one more thing I want to do with limits as x approaches infinity, and I think it's going to take like 5 minutes, but I don't want to tack it onto this video because it feels different than what we did in this video, so I'm going to say it for the next one.